All right, Stephen, just like a good croissant, Micron has decided that they've built a new treat around a ton of layers. The storage maker has announced that they have a new 232-layer NAND Flash offering that is the first in the industry to cross the 200-layer boundary. Now, the reported specs on the unit are pretty impressive. I saw the throughput numbers and they were mind-blowing. But the real area that is crazy is in the areal density of those chips. You got to think about how much you can pack into a layer cake that's 232 layers. Where is that real world impact going to be felt? Well, it's going to be felt in really small things like portable video game consoles and mobile phones, because now they have access to a lot more flash that they would have been able to have otherwise. And Micron is the first to beat other companies like Samsung out of the gate, because Samsung is trying to get their product out before the end of the year. Stephen, you're the storage expert. Is stacking NAND like this going to lead to better performance, or is it going to lead to bigger problems if it eventually fails?
Yeah, this is great news from Micron. Well done, folks. You did a good one here. It's important to think of a NAND chip as basically a little skyscraper. And just like a skyscraper, you can fit as many people into the apartments as you can fit. The easiest way to pack more people onto a city block is to build higher, right? That's pretty much what Micron is doing. So imagine instead of a 232-layer NAND chip, imagine we're talking about a 232-story building. Well, that's kind of terrifying, but imagine it anyway. A 232-story apartment building, and each of those apartments still holds the same number of people. So you can imagine that going from 176 stories to 232 stories is really going to improve things. But you can also imagine that there might be some trouble here, right? Maybe that building's going to use more power. Maybe that building's going to take a longer time. Maybe there are going to be like a lot of people waiting for the elevators and the stairs all the time. Well, the cool thing that Micron did here too is not only did they increase the number of layers, they also increased the number of access lanes or planes here. So imagine this new building has a whole bunch more elevator banks than before. They made it more efficient as well. They've got a lower voltage support. Again, stretching my metaphor, suddenly all the houses have special super efficient appliances and low voltage light bulbs and things like that. And the net result is that they've got a device here that stores a lot more data, a lot more efficiently on a lot less power. Everything is improved. Performance is improved. Capacity is improved. And frankly, the fact that the chip uses lower voltage means that it's going to be much better for the next generation of portable devices. Honestly, this thing is great. It's way out ahead of the industry, and Micron did a really, really nice job here. In fact, I am hearing rumors from my friends in the analyst community that they may have already scored some pretty notable wins for this technology that they really can't talk about, and neither can anyone else. So if that's the case, I just can't wait to be able to tell you more about that.